Hey everyone, today we're going to be talking about derivatives of inverse trig functions. And so this is going to be similar to what we've been doing, right? Because we've been working with derivatives of inverse functions. However, now we're specifically working with inverses of trig functions. And these are going to be a little different because instead of working through that three-step process that we worked through for inverses of functions, the derivatives of inverse functions, these we're just going to have rules that we need to memorize. So much like when we learned our derivatives of trig functions, we're going to have to memorize these derivatives as well. Okay, so there's no three-step process. We're just going to memorize the derivatives, so then it just becomes a mechanical process of using those derivatives. So the first thing we're going to go through is just go down and list all the derivatives of these functions. So the first function we have is our inverse sine here. Okay, and so the derivative of inverse sine, if I have inverse sine of u, is going to be 1 over the square root of 1 minus u squared times du dx. Now, what I want you to realize, this I know looks a little confusing, this is the derivative right here, the 1 over the square root of 1 minus u squared. This times du dx is going to account for any chain rule that we might have in the problem. So we'll kind of look at that more closely when we start to go through some actual examples. Okay, so now my cosine. It's going to be the same format here, but now because it's cosine, it's going to be the opposite of 1 over the square root of 1 minus u squared times du dx. Okay, inverse secant is going to be 1 over, now we have the absolute value of u times the square root of u squared minus 1 times du dx. Cosecant, again, kind of same rule, except it's the opposite. So negative 1 over the absolute value of u times the square root of u squared minus 1 times du dx. And then the last one is inverse tangent. The derivative of the inverse tangent is just going to be 1 over 1 plus u squared times du dx. And so cotangent is just going to be the opposite of that. Okay, so those are our new 6 derivatives that we have to have memorized. And these will come up quite frequently on the AP test, so you really want to make sure you memorize these pretty quickly. So let's look at some problems that use these. So for number 1, we're just finding the inverse sine of x. And so the first thing I notice is I just have an x here, so I actually don't have to worry about the chain rule for this example. So I'm just using my rule up here. So in this case, my u is really x. So f prime of x equals 1 over the square root of 1 minus x squared. And again, because I don't have a chain rule, I don't have to worry about that other part. Okay, for number 2, I have inverse tangent now. Again, this is just x, so I don't have to worry about the chain rule. So this is just testing, do I know that derivative? So for inverse tangent, I know that's just going to be 1 over 1 plus x squared. Okay, now we're going to look at number 3. So in number 3, I notice now I don't just have the inverse sine of x. I have the inverse sine of x cubed. So if we kind of look back to our formula, that's really that u, right? And because it's x cubed, now I know that I do have to use my chain rule. So I have to remember that when I'm working through this problem. So I know that dy dx, I'm going to start off just by differentiating my inverse sign, and my x cubed is going to stay the same. So I'm going to have 1 over the square root of 1 minus, now I'm going to have my x cubed, and I'm going to square that. Now I have to differentiate the inside, so this x cubed, so I'm going to multiply by the derivative, which is 3x squared. And so I'm just going to simplify this a bit. My 3x squared goes up in the numerator. I have the square root of 1 minus x to the third to the second power is going to be x to the sixth. I know I have to multiply those exponents. Okay, number 4, I have inverse secant. Again, because this is not just x, it's a 2x, again, I have to watch out for that chain rule. So let's see how this one's going to work out. I know I'm going to use this notation here. Again, we have to be familiar with all the different types of notation. So I'm going to say y prime. Now, if I'm inverse secant, that's my formula here. And my u in this case is my 2x. So I have 1 over the absolute value of 2x times the square root, u squared, so that 2x, that whole quantity gets squared, minus 1. And then I need to multiply by the derivative of 2x, so I'm going to multiply by 2. So now I'm going to simplify it, and I'm going to show you a couple things that we need to be careful of here now that we have this absolute value. So on top I have my numerator, which is 2. Now, if I look at the absolute value of 2x, we know that this 2 is already, right, a positive number. So since that's positive, it does not have to stay inside the absolute value. It can come out front. So we're going to pull that 2 out front and just leave our x in the absolute value. And then I'm going to go ahead and simplify what's under the radical. Quantity of 2x squared is going to be 4x squared minus 1. And so now I see, now that I've pulled this 2 out, I can cancel these, so I'm just left with a 1 in my numerator. So my final answer is 1 over the absolute value of x times the square root of 4x squared minus 1. All right, we're just going to do a couple more. I'm only going to do 5 and 6, and then when we get back to class, we can always go through 7 and 8 if we need to walk through more examples together. So for right now, let me just scoot down and we'll do number 5. Okay, so now, again, I've got inverse sine, and the first thing I recognize is I have the square root of 2t, which is telling me I'm going to have to use my chain rule. So let's go ahead. I know that y prime is equal to, well, my inverse sine is 1 over the square root of 1 minus my u, my square root of 2t, and I need to square that. And then I need to multiply by the derivative of the square root of 2t. Well, I know the square root of 2t is just 2t to the 1/2. So when I find the derivative, I'm going to have 1/2 times 2t to the negative 1/2. And now I actually have to use my chain rule here. So I did my outside, which was the power rule, and now I need to find the derivative of my inside, the 2t, so I'm going to multiply that by 2. And again, now it's just a matter of kind of simplifying. This 1/2 and the 2 are going to cancel each other out. And this 2t, since it's a negative exponent, is going to end up in the denominator. So my derivative now, I just have 1 in the numerator. I'm going to move the square root of 2t down to the denominator. And then I have multiply by this 1 minus. Now the square root of 2t squared is just going to give me 1 minus 2t. And that's my derivative. All right, so we'll do one last one for tonight. Again, these are pretty straightforward as long as you have the derivatives memorized. Number 6 here is just going to be a little more complex in the type of simplification that we're going to do. Okay, so my derivative, dy dx. Inverse cosine, I know, is the opposite of 1 over the square root. Now I have 1 minus 3 over t squared, and I'm squaring that quantity. And then I have to do the derivative of 3 over t squared. Well, I know that's just the same as 3t to the negative 2, so this is just a simple power rule. So if I multiply negative 2 times 3, I'm going to get a negative 6 t, and then I'm going to subtract 1 from my exponent, which will give me a negative 3. All right, so let's see here. Now I have a negative times a negative, so I'm going to have a positive 6. I'm going to go ahead and move this negative exponent down, so I'm going to have a t cubed in my denominator. And now I have times the square root of 1 minus, I'm going to have 9 divided by t to the 4th. Now, this is one of those cases where this is a correct response. However, if I were doing this on the AP multiple choice exam, this would not likely be a response on that test. So I have to work through what else this could look like, do a little more simplification. So here's what I'm going to do. Under the radical, I have 1 minus 9 over t to the 4th. So what I'm going to do is get a common denominator with both of those terms. So I'm going to block this off here. I'm going to keep my 6 up top, my t cubed on the bottom. But now I'm going to rewrite 1 as t to the 4th over t to the 4th. So what I can do is make this actually t to the 4th minus 9 over t to the 4th. So I've just given that a common denominator of t to the 4th. And here's why I'm going to do that. The square root of t to the 4th minus 9 over t to the 4th is really just the square root of t to the 4th minus 9 over the square root of t to the 4th. Well, I know the square root of t to the 4th is just t squared. So in my next step here, I'm going to take this 6 and again my t cubed. But now what I really have is just the square root of my numerator, t to the 4th minus 9. And the square root of t to the 4th is t squared. If I write it like that, now I can see that t to the cubed, or t cubed over t squared, this can cancel, and I'm just going to have a t out front. So now that leaves me with a much kind of simpler looking answer, which is just 6 over t times the square root of t to the 4th minus 9. So that's definitely the trickiest problem because of that simplification. But again, the big idea here is really to make sure you have these derivatives memorized and that you can apply them, especially when you have problems that involve the chain rule. So today was a pretty short video, so I would recommend you kind of start quizzing yourselves on these derivatives. Maybe even try 7 and 8, and like I said, if we need to, we can go over those or any other of these problems in class when we're back together. That's it for today.